Have you ever tried explaining something to someone like step by step and they just aren't getting it?
Yeah.
And then finally,
Yeah.
it's like that aha moment hits.
Right.
Well, today's deep dive is all about helping AI
Okay.
have more of those aha moments,
Interesting.
especially when it comes to like logical thinking.
Yeah, it's one of the biggest challenges
Yeah.
in artificial intelligence right now. We have these large language models, LLMs.
Right.
They can write like Shakespeare one minute and then debug code the next.
Yeah.
But getting them to think logically
Okay.
and consistently solve problems that way, it's tough.
It really is. It's like they can ace the essay portion of the exam.
Totally.
But then when they get to the multiple choice,
Yeah.
they just completely blank out.
Exactly. And that's what's so fascinating about this paper
Okay.
is they found a potential way to improve that
Really?
by focusing on how we reward these LLMs during training.
Okay, so instead of just grading the final answer,
Right.
we're looking at their work, seeing where they went off track.
Exactly. Yeah. It's like
Interesting.
instead of just saying right or wrong at the end, you're giving them feedback along the way,
Got it.
which is way more helpful for learning.
Makes sense. So that's where these process advantage verifiers come in.
Yes, exactly. Or PAVs for short.
PAVs, okay.
Think of them like AI tutors
Okay,
that can analyze each step the LLM takes
got it.
as it tries to solve a problem.
So it's like having a more experienced student kind of guide their peer,
Yeah,
be like, hey, this step is good.
exactly.
This step, not so much.
That's a great way to put it. And it's really cool because they found that a slightly worse prover,
Okay.
one that wasn't as good at solving the problems itself, could actually be a more effective tutor.
No, that's interesting. Why wouldn't, like, a straight-A student be the best tutor?
Well, because sometimes being too far ahead means you miss those aha moments.
Right.
Those subtle leaps in understanding that someone who's also learning might catch.
Okay.
It's like imagine a tutor who remembers what it was like to struggle with the material.
Okay.
They can empathize and provide more targeted feedback.
That makes sense. So how did they actually test these PAVs?
So they decided to train these LLMs, specifically Google's Gemma model,
Okay.
on this challenging math problem dataset called math.
Math. Okay, so are we talking algebra, calculus?
Oh, yeah.
Words.
Absolutely. Problems that would make even some humans sweat.
Wow.
And remember those solution traces we talked about?
The step-by-step breakdown.
Yes, exactly.
Calculus.
They used a separate, slightly better performing prover LLM
Check.
to generate these solution traces for the math problems.
Got it.
And then they used that data to train the PAVs to recognize which steps actually indicated real progress.
So it's like they created this whole curriculum
Yeah,
based on how this really good prover solves math problems.
exactly.
And then they use that to teach the base LLMs.
Precisely.
Interesting.
And the results were fascinating.
Really?
Yeah. The LLMs trained with these PAVs, they actually significantly outperformed
Wow, really?
the ones trained with the traditional outcome-based methods.
So like how much better did they
We
do?
were talking like improvements in accuracy of up to 10%.
10% on these like complex math problems.
Yeah, and that might not sound like a lot.
But in the AI world.
Yeah, in the world of AI research, that's huge.
That's like finding a shortcut
Exactly.
that shaves like months off a rocket's journey to Mars.
That's a great way to put it. So it's working, but like, why?
Yeah, what's going on?
Why are these PAVs so effective?
Yeah.
Well, one of their key findings was that simply rewarding the LLM for rephrasing the problem often led to dead ends,
Oh, interesting.
even if technically correct.
It's like that student who tries to sound smart
Yes.
by just rewording the question,
Exactly.
but doesn't actually know how to answer it.
They're just spinning their wheels. And this is why focusing on actual progress, not just generating technically valid but ultimately unhelpful steps, is so important for effective learning.
So it's not enough to just like
Right.
spit out a bunch of different ways to say the same thing.
Exactly.
It's about actually like making headway towards
It's about the process.
a right answer.
Yeah, and that's where the PAVs really shine.
Okay.
Because they don't just say right or wrong.
Yeah.
They can provide much more nuanced feedback,
Go.
recognizing those aha moments, even within a solution that might ultimately be incorrect.
So even if the LLM doesn't get the final answer right,
Yeah.
it's still learning
Yes.
about the process of problem solving.
Precisely. It's like a coach who analyzes each move an athlete makes, providing feedback that helps them improve their technique even if they don't win every single game.
Interesting. Okay, so we've talked about this improvement in accuracy,
Right.
but you also mentioned earlier that using PAVs was more efficient.
Yes, absolutely.
So what did the research say about that?
So they applied PAVs to something called online reinforcement learning.
Okay, what is that?
It's essentially fine-tuning the LLM as it learns.
Also, instead of like waiting till the end to be like, hey, you did this wrong.
Right. It's like real-time feedback.
You should have gone left instead of right.
Exactly.
Okay.
And what they found was pretty incredible.
Yeah.
They found that by using PAVs as these dense rewards during training, they saw a 5 to 6-fold improvement
Wow. That's a lot.
in sample efficiency compared to using only outcome rewards.
So it's like finding a way to teach a dog a new trick, but like way faster.
Yeah,
Okay, that's huge, especially when we're talking about these massive language models.
absolutely, because training these things takes a ton of computational power.
Right.
This increased efficiency could make it possible to train more sophisticated LLM with fewer resources.
Okay, so that's like democratizing
Mhm.
access to this kind of technology.
Exactly, that's the hope.
Wow, that's really cool.
Yeah. Yeah.
So we've got these amazing results.
Yeah.
More powerful AI, potentially more accessible AI.
Right.
But like every exciting new breakthrough,
Sure.
there are probably some caveats here.
Of course. Yeah.
So what are some limitations that the researchers pointed out?
So one of the key challenges is selecting the right prover policy.
Okay.
They were able to find good provers for their experiments,
Yeah.
but it's not an exact science.
Oh, it's like finding the perfect tutor.
Exactly, and that's something they want to explore more in the future.
Interesting.
Another area for improvement is the reliance on these trained PAV models themselves,
Okay.
because they can be complex and prone to errors.
Oh, so the tool that's helping the AI learn
Yeah,
could also make mistakes.
exactly.
It's like a bit of a chicken and egg thing.
In a way.
Okay. Got it.
And because of that, the researchers have suggested exploring methods that might be able to estimate progress without needing these separate PIV models.
So like cutting out the middleman. Okay. And what about other avenues for using these PAVs?
Yeah, so their research focused on math problems,
Right.
but the applications could extend way beyond that.
Okay.
Think about things like writing code,
Yeah.
generating scientific hypotheses,
Wow.
designing complex systems.
Things that require a lot of reasoning.
Exactly. Anything that requires that logical reasoning could benefit from this kind of granular feedback.
So we're talking AI that could like write better code than human programmers,
Potentially.
make incredible scientific discoveries.
It's possible.
Pretty mind-boggling.
It really is, and it all comes back to this idea of rewarding progress, not just outcomes.
Yeah, that's really got me thinking. Yeah, it really is amazing how much of like human learning is about those tiny steps.
Totally.
You know, those moments where you're like,
Yeah.
almost there, almost there.
It's not like we learn to ride a bike in one go.
Right.
It's all about like practice and feedback and those little bursts of insight.
And this research is showing us that those same principles
Yeah.
can be applied to artificial intelligence.
Exactly.
Like by shifting our focus from just the destination to the journey,
Yeah.
we can unlock this whole new level of learning for these LLMs.
It's like we're giving them the tools,
Yeah.
not just to mimic us, but to think for themselves in a more structured way.
And this is just the beginning, right?
Oh, yeah, absolutely. This is just scratching the surface.
Like as researchers keep digging into this,
Yeah.
who knows what we're going to see?
It's really exciting to think about.
Like we could have AI working with scientists
Yeah.
on these groundbreaking projects,
Just-
designing things, solving really complex problems.
And doing it in a way that we can't even imagine right now.
But we also have to remember that this comes with responsibility.
100%. Yeah.
It's not just about what AI can do.
Right.
It's about what they should do.
We have to make sure it aligns with our values.
Exactly. Because this technology is powerful.
Yeah, this research really highlights that
It's not just about building smarter machines
it's about building a better future.
where AI and humans can kind of grow together.
Couldn't have said it better myself.
Well, on that note, I think we've reached the end of our deep dive
This was fun.
into the world of rewarding progress in AI.
Yeah, thanks for having me.
Always a pleasure. And for everyone listening,
Yeah.
keep those questions coming and keep your minds open to the incredible possibilities out there.